Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are trying out weekend streaming here, and well, I don't know that it's going to be that much different than weekday streaming, but we're going to do 2 episodes back to back is basically the difference. So instead of doing 1 episode every weeknight, we're going to do 2 episodes on Saturday and 2 episodes on Sunday and see how that works. The idea here is just to make it so that we can have more of a continuous workflow, because 2-hour blocks tend to be better than 1-hour blocks in programming in my experience just normally, especially when you factor in the discussion that has to go on. So, you know, there's a certain less amount of coding that can actually happen when I'm explaining things, obviously. And so in order to try and make it more possible for us to do bigger code changes a little more smoothly, we're just going to see how that works. So what I'm going to do today is finish what we were doing before. Today is day 350, so you want to start with day 349 source code if you want to do that, if you want to follow along. My voice is in bad shape for some reason. I don't think it's the talking. I actually think that it is a little bit of a cold. I got my flu shot. So I don't know that I have the flu, but I might have like fighting off the flu or something. I don't know what. Anyway, but I hadn't been feeling well the past couple of days, so we'll see. Anyway, what I was working on when we last left Handmade Hero a week ago was I wanted to make it so that we could simulate multiple regions at the same time. And we basically did that. So I showed at the end of last week's stream an example of simulating 2 separate regions in the world concurrently. And it worked just fine. So that's good. But we have a few more things to deal with here. And we have to deal with the sim region merging. I don't know that we're going to have to deal with parentality clocking, but we need to talk about both of them. However, before we get to there, oh, and this got fixed. Before we get to there, I want to do one other thing and talk about why I'm doing it and how I'm doing it, because it's something that I think is important to kind of know and be aware of, so you can kind of, it's just a general, it's a fairly standard code transformation if you're an architecture kind of person, and I just want people to understand what's going on and why. So if you remember how we made this work, we have a function called update and render sim region. And what update and render sim region does is update and render sim region allows you to say this block of the world needs to be updated. And that way you can pick any block of the world that you need to update and have it update. Doesn't have to be only 1 per frame. We can do 12 per frame if we want. We could farm them off to multiple processors. We can do anything we want, really. But when we did this, one of the things that you'll notice, and a lot of times people ask me what I think of functional programming, and I always say the same thing, which is I think the functional program is really good. I don't think it's the kind of thing that you should apply everywhere, just like most programming practices aren't the kind of thing you should apply everywhere, but functional programming is definitely something that's worth understanding and worth applying in a number of circumstances. Well, one of the things that you can sort of think of that's even a little bit more general than that is really just more the concept of state visibility sort of minimization. And what I mean by that is any time that you look at a function, it's very instructive to know what it is that that function actually requires to do its job. Meaning, what state in the system does this function need to access? Now, in a purely functional context, one of the reasons that, like I say, functional programming is a good thing is because in some contexts you can get you can get a function down to the point where it doesn't actually modify anything. It only has to look at things, right? Meaning the parameters that you pass in are immutable, and the only thing that you're interested in coming back from the function is the return value which you're going to use. And this obviously pays a number of dividends. Any number of such functions can be called concurrently without any locking or anything, right? Because if all you do is look at the state of something and then return a value, you don't have to worry if 2 things are doing it at the same time. right? Two things that are doing that at the same time will still produce completely correct results because they're not touching any of the things that they're being handed. They're being given this information as purely advisory, and they are not allowed to go in and muck with it, right? This is what people mean when they say no side effects of a function, right? It means that when I call the function, it's not going to touch anything. It's just going to return a variable back to me, and that's the only thing that it's going to do. So that's very powerful for a number of reasons, right? Another reason that's very powerful is it means that you don't have to wonder about what that function is going to do when you call it. So for example, in this circumstance, when we had two of these guys here, you can kind of see that when I call this update and render sim region, there's a lot of stuff getting passed here that I wouldn't really want to be touched or accessed in the case where I was simulating something that wasn't getting rendered. So for example, we pass the render group and the draw buffer here. Well, the render group and the draw buffer are pieces of information that only someone who's going to display information to the screen would need. And so you can tell right away that this function really, at this point, isn't quite right in terms of how it operates and what it needs, because sometimes we want to call it in ways that don't involve using those parameters, and those end up getting nullified out, right? Okay, so when I look at this, that definitely gives me some concern. And if you look at how the system is architected currently, when we want to call this thing twice, if I didn't, when I did this before, I'm going to look and see if I can make that debug camera be a little further out as well. Where is, I don't really remember what that's called. Hold on a second. It's called render camera debug distance. So if I do a search for global render camera debug distance, all right, or not. Probably spelled that wrong. Here it is. I knew it was here anyway. I don't know why I searched for it. I missed the underscore. All right, I'm going to just make that be higher up. So if we take a look at what happens here when I run the program, and I turn on the debug stream here, that still probably wasn't enough. Let's make it even further. Because we don't have good sliders, so I don't want to have to edit it there. It's a pain in the butt to edit it every time. So if I switch this here, we should be able to see. Still not enough? How far is it? It's really far. OK, so maybe we want something more like 150 or 200. So now that I've got the camera far enough out, if I do switch to the debug camera, there you go, you can see that second debug region down here, and we do want it rendering, right? So it's OK that we pass in the render group there. But now let's say that I'm talking about the game in a more realistic setting, not in a debug view, and I don't want that to be drawn, right? Well, what I do when I don't want that to be drawn in the way that we currently have the code structured is I just get rid of these things that I'm passing, right? I just say, I don't want you to access the render group, and then you won't. And now that simulation is still occurring, right? You can still see we've got that all that extra work being done here, right? That super unoptimized function that takes all our time. But when I zoom out, it's not being drawn. And that's exactly what we would expect to see because it shouldn't be, right? And you know what? What's interesting about this, too, is you can kind of see another bit of leakage that's happening here. In fact, this is a really good example of why I want to do the code change that I'm going to do, too. You can see that the particle systems are active down here, right? I don't know if you guys can see that, but there's little particles being emitted here. And the reason for that is because, hey, anytime you're in part of the simulation, it's going to want to generate particles, right? That's what happens in these circumstances. Particles get generated, right? So it's not that we can't do what we want to do with this. And even for the particle system part of it, I could do the exact same process. I could make it so that when I call update and render sim region, I have, fundamentally speaking, just some stuff that I pass in here, right? And that's a totally reasonable way to structure code if that's the most efficient way to do it. And we may want to keep it that way, but there's at least one thing that I think I probably don't want to keep that way. But we'll sort of talk about that in a second. Um, so if we take a look at what's happening with update and render sim region, what we've effectively done is said, okay, rather than breaking this up into smaller functions and calling the ones that we want, we've kept it monolithic so that it does what it does. And then inside that monolithic function, we've put an if statement that says, hey, if you are in a place where you wanted me to process input, then I will do the stuff that I was going to do for that, right? And similarly, you get kind of a similar situation here where, like, if I go down to update and render entities, and I look inside that function, which is sort of a sub-function here of the simulation update, if we look at what's going on there, the same thing is true. The simulation code is here and will do the operations it needs to do to do the simulation. But then the render group is switched on and says, well, if there is a render group, then I'll go through and do this rendering that I needed to do for this entity. But if it's not, I'll just ignore all of this code altogether. None of it will become active. And again, for the particle system stuff, since we have this problem of spawning particles, you can kind of see here with the particle cache, what we'd want to do is the exact same thing here, right? We'd want to basically say, hey, the particle cache should be something that's passed down to us, and if we don't have one, we shouldn't be doing this operation, right? So that's one way to structure the code. And what it essentially means is that when you are doing this particular operation, you're going to pass in a superset, potentially. Not a proper superset, perhaps, but a superset of all of the things that you might need to complete the operation. And then you are going to selectively switch some of them off, and the code that is using them will know when you've done that not to perform certain aspects of their function. And it's important to internalize when this is happening and why. So we could equivalently say, let's break this up into two phases, update and render, which are separate, right? And if we did that, then we would only pass the render operations to the render side, and we'd only pass the update operations, or information rather, to the update side. And if we do that, that would make this code a lot more understandable and digestible, because it means that you don't have the two parts sort of commingled together. The problem is, if we did that, we also pay potentially a very large cost. And the cost that we pay is that in doing so, we would force the code to look like this loop twice, meaning we would have to loop over all the entities that we were concerned about in the sim region 2 times. And in doing that, that means we are bringing all of their information back into the cache both times. This can be very expensive, right? That can be a very expensive thing to do. Now, we don't know a priori which method's cache usage is actually better because we haven't measured it. It could be that the things that we're doing, because we also do the rendering and have to push things on the push buffer in that case, or whatever, it could be that for some reason we don't come out ahead cache-wise if we by merging the two together. But it could also be that we do. And so it's always a trade-off here. When you look at these, simplifying functions down so that they take less things is definitely something you want to do if you can without paying any costs, but in some cases you have definite costs, and this is potentially one of them. So what I want to do here is just show how we would remove some of this if we wanted to. I'm not going to split up update and render yet because, like I said, I'm not really confident that that's a good decision. There's nothing wrong with writing code this way. Again, there's obviously a lot of demagoguery in programming, and people often say, you have to split up concerns or keep things in class and blah, blah. All of that stuff is obviously, not true, right? CPUs are CPUs. They execute code. They know nothing of these things. And so the only thing that really matters at the end of the day is the shipping product. Were you able to write it efficiently? Did it work okay? Did it take too long to debug? All those sorts of things. Measurable outcomes is the only thing that matters. And so in this case, again, with something like this, both ways of structuring the code are totally valid. They just have trade-offs. And it's a question of which of those trade-offs is the right one to make in this circumstance. So here, where we have the render group coming in, and that sort of stuff. I'm not going to touch that. Instead, what I'm going to do is just show how we might address this situation for a part that I think is absolutely of no cache concern, is no performance concern. There's probably no reason why it would have to do it that way. And that is this part right here. So you can see that we have look to see if any players are trying to join, right? And this is clearly, if you look at what's going on here, there's obviously no real reason why this would have to be done in line with anything. It's doing its own loop over controller data. Nobody else is participating in that loop. There is no shared data here with this and the thing that comes after it. There's really not a lot of argument to be made regarding why this has to be part of this function. It's really a separate thing. It could be broken out. But of course, what we find when we do break it out, like let's just do the very straight cut and paste here. If I wanted to start, again, taking a small step to remove that from the code where it was and putting it in its own separate function, what I will find very quickly is that it relies on something that is not possible to be extricated directly. So let's say that we do this, and this is, I probably should keep the comment as well. Let's bring that back up here. So put that in there. Check for joining players, let's say. Seems like a reasonable name for this function because that's what we're doing. And we know in this case that we need to pass the game input because it's going to loop over that. And you can kind of see some of the other things that this needs. It needs the game state because that's where the controlled hero function array lives, where it can check things out. And now let's try to, we'll try to put that in here, check for joining players. And we'll pass that game state in the input. And then we'll just see what we need. So we need camera P, which is where the hero is going to show up. We need the sim region, right? And those are pretty easy things, again, to add in here. Not particularly hard. I want that. I want the sim region. Where did that go? Sim region. Sim region. And the world mode. And that's all that that function needs at the moment. Let me go ahead and pass those in. Let's see, I need that, I need the sim region, and I need the world mode. Remember where we put the world mode. In the parameter list, it's right after game state. So there I've called it, right? And so now the question is, well, like I said, I don't think that wants to be an update and render sim region, so let's go ahead and move it out. And what we find when we do this is the thing that I wanted to talk about and just sort of mention. So let's say I wanted this to be moved out, so I put it here, and I'm like, good to go, this is going to be great. We'll compile it. OK, we have the input, we have the game state, and then we get to these two guys right here, sim region and camera P, and we're like, we don't have them. Now, there's nothing we can do to get them, because if we take a look at where what's going on in here, this function that we want to call, that we didn't want to be doing this operation, it's actually necessary for it to have been doing what it's doing with the begin sim, right? That's actually necessary. Right? That's an actually required aspect. And in order to get the camera P, the same thing is true, right? We need the sim center, which this thing was computing. So if we take a look at what that means, it means that we have a thing that's optional, right? We only want to call check for joining players this first time. We don't want to do it this time, right? It's not something that's supposed to happen in all of the times that we are simulating regions. So we only want to call check for joining players just that one time, but we find that we can't, because when we call update and render sim region, it's going to do some work that's necessary for us to be able to finish, for us to be able to actually perform this function. So what we need to do fundamentally is break up update and render sim region into multiple pieces that can be controlled in a more dynamic fashion, right? What we want to do is do something like we have here where we do begin sim and end sim. We want something more like that. We want to be able to call begin sim, end sim, and in this case we call check for joining players. In the other case we just call begin sim, end sim, and we never actually call check for joining players in between, right? So that's a fundamental kind of code transformation we want to be able to make. It's a kind of code transformation where you're basically saying we have something that all has to happen in line, but some of the parts of it want to be optional, and we don't really want them to be sort of welded in to that code, because we want the person calling it to be able to sort of control the order of how they're happening, or have more control over whether they happen at all, and we just feel more comfortable with that being the way things work. And so what we can do here is we can sort of expand our notion of how that begin sim, end sim works. Because if you look at how this happens, beginning the sim region is really kind of a lower level operation. It's really not begin sim that we're calling here. What we're saying is open up like a piece of the world for edit, right? Is what that is. So really we kind of, the naming here is sort of what's throwing us off. It shouldn't really be called begin sim. It should be called like open world region, and then we should have a like closed world region or something like this, right? And then begin sim is a higher level thing that happens, which does the open, but also does a few of these other things, right? And then inside there, we would have thing that's like a call, for example, simulate, which we don't currently have, and sort of makes this all look a lot more like a sort of a reasonable control flow that we can manage. So here's begin sim and end sim and check for joining players, right? I know that that's one thing I want to have happen. So probably if we looked at how this, we wanted this to look here, we could do something like this, right? And maybe, you know, there'd be an opportunity for us to actually you know, do something even more specific there. Like, for example, the particle system rendering could be something that sort of happens only in one place as well. You know, we could do something like here we do render particle systems, and then that, you know, thing could come out as well, because as you can see from here, this stuff is all, in fact, you know, right? This stuff is all kind of extractable. Right? It's something that can come out. And similarly, like this debug information as well that we had here, that can come out equivalently. So, you know, if we look at what this is going to look like, you know, this starts to look a lot more reasonable to me, because now we're starting to kind of get this this function starting to look a lot more sane, and you can kind of now see much more clearly at the higher level what the difference is between these two operations. You know, one of them is clearly just going to simulate an area. One of them is going to do a bunch of other things. In addition to simulating the area, it's also going to check for the players that are joining, and it's also going to update and render the particle systems and things like this. So again, just talking about kind of that motion, hopefully that gives some understanding of how that's going to work. So let's go ahead and actually implement that code change, just so you can kind of see what that looks like. So suppose that I'm going to take here and go down to, I probably shouldn't quite have moved everything out yet, but you know, that's okay. We'll deal with it. Suppose I go into sim region here, and I just, again, call this something a little bit different. Because if you think about this being called a sim region, again, it's not really quite what it really means. It's really more of just an open region of the world. And in some sense, you could even think, if we take a look at what's happening here, in some sense, really, you can start to see the sim region stuff and the world are really just probably should be welded, right? This is kind of a thing that we're working on, that sort of how they sort of pair up with each other. And what you can see is like the simulation side of things and the like packing and unpacking of entities side of things are really two very different functions, right? You can see in here that really all this is doing is opening up the region. It's copying out all of the entities into an editable state, and then giving it back to you, right? And similarly, then we have, when we close it, we have all the same stuff that's happening here, right? That's exactly what's going on. And so really, like I said, it's not begin sim and end sim. That's not really what's happening here. It's really more like, you know, begin world edit, right? and end world edit. That's what's actually happening, right? And we could also call it changes if edit's a little too confusing. Begin world change, something like that. And I'm not sure what the best word is for it, obviously, but it's something along those lines. So then, that's a pretty simple name change. All we're saying is it's now begin world change instead of something else. This is end world change. Again, not particularly strange what's happening here. World change and world change. And then we're left with just the things that are actually world sim. Right? Okay. So now we have to address what this is actually happening here. So, now we have to say, okay, we've got a thing that probably will return a sim region. It's going to be called, begin sim. And then we're going to have a thing that does an end sim. And if you look at what's actually going to happen there, you can see that there's a lot of additional stuff, right? Here we go. We've got our begin sim. Then we've got our actual simulation step, which is this. And then we've got sort of our finishing step, which is this. Right? And if we take a look at what's happening here in terms of passing down like the mouse P and the world and that sort of stuff, we could probably mostly deal with it like this for now. Split those up wrong. There we go. And now we can start to sort of play with the consequences of that and just like make sure that we've kind of gotten them under control. So if we take a look at what we need to pass in terms of update and render sim region and all that sort of stuff, so we can take a look at begin sim here. We can take a look at this list, and I'm just going to paste that list into all three of these and then start eliminating the things we didn't really need. So now you can see that end sim itself really doesn't need very much at all. It really just needs that sim memory. We're going to have to deal with that in a second. And then it needs the sim region and the world mode. So those are pretty easy things to pass in. So there's the sim region. And we're going to have to pass in that, what is it, temp memory? Do not remember what that's called. Temporary memory. So it's going to need that sim memory so it can end that, right? And then it's going to have to do the world change stuff. So we'll deal with that in a second, but that's it. I don't really know what this is talking about per se in terms of the camera update. I guess that's happening inside here, so we should probably leave that comment so we can take a look at it. But here's our simulate function. Let's take a look at what that needs. So again, it needs mouse P at the moment, so we'll leave all the stuff in there that it actually needs. World mode, it probably needs most of this stuff, right? But again, it's going to need some things from up here. So it needs like the camera P, for example, is something that it needs to know. And so let's start figuring out how to get that information sort of encapsulated. So I don't know what we're going to call this. I guess we'll call this, world sim or something like this. And in here, we're going to sort of store the information that we needed to flow through. And in fact, I guess what I can do is I can actually make this probably contain these two. So it's like a convenient way to pass them through. All right. So here we'll pass the world sim. That will have the region in it. And the sim memory. And then similarly, like over here, begin sim would return that. So we have our results, and we'll just fill it out. And that's it. So when we call simulate, we're going to have to probably pass in the sim region, and I guess the camera P is probably also important here. And all of that stuff now can come out from this system, right? And similarly, we could save anything that we wanted to save here, that we needed to save here, out of things that if we needed to. DT is not really necessary to be passed in here, I would think. In fact, why does begin world change require the DT? Does that make sense to you? It doesn't make a whole lot of sense to me. Was that something that used to happen and doesn't have to happen anymore? Is there a reason for? Oh, I know why. It's because it needs to know how much to widen it by. So I guess it does. Because things that move faster would require bigger sim bounds potentially. All right, so render group and the draw buffer and game input probably don't need to be passed here, right? So none of this stuff has to be passed. The background color doesn't have to be passed. So I think it's only the screen bounds potentially. Actually, even the screen bounds I don't know need to be passed. So just a lot of things don't have to be passed here, right? It's really just these. And so begin sim becomes a much sort of simpler and more understandable thing at this point, which is nice. And then we can just return this out. And we can require that it be passed back in. Now, if I look at the trans state here, the assets is really the only thing that needs to get passed through. So I might just say that that's something that gets passed here. Because again, that would not really need to be passed in circumstances where you weren't rendering. And so that could become important later. Right? All right. So we want to pull out the sim region, because we need that. We want to pull out the camera P. And that's about it. OK. All right. Now, what else do we need here? Is there anything that we don't need? I don't know that the screen bounds is necessary. Screen bounds is not necessary. How about the game state? Game state is necessary for brain execution. We can probably get rid of that eventually. I think we probably will. Background color is necessary. Sim bounds and DT. Sim bounds not necessary because it's already encapsulated in the sim region itself. So I think that's it. The world sim, the world mode, the DT, everything's good. That's about it for that. So now let's actually go ahead and call these. So inside our update and render world, we now have this sort of world sim that we're calling. And we're just going to go ahead and pass what it wants. Right, so nothing particularly unusual there. We're just passing what we're supposed to pass. And then what we're going to do is call check for joining players, which we know we can do now because we've got our world sim. We can sort of pass through the information that we need to pass through. We can then call simulate. There we go. And we just need to know what that's going to take for parameters, right? So here's simulate. It's going to take the world sim. It's going to take the world mode. It's going to take the DT. It's going to take all the rest of the stuff, the background color, game state, the assets, input, the render group, the draw buffer. And you got to spell game state right. Not good if you don't. So here's the DT. And let's go ahead and correct that out. Frame to frame camera delta P. I'll be honest with you, I don't remember where that's computed. Let's take a look and see. So here we are. And frame to frame delta camera P is produced up here. it looks like, if you'll excuse me for a second, I want to put on my hoodie here. There we go. It's just getting a little cold. Okay. So yeah, what I was saying is I don't remember whether that was computed. Well, it's computed right here, and here's the subtraction. Frame-to-frame camera delta p is only used for particle systems, I believe. Yeah. So the frame-to-frame camera delta p is something that probably should be moved because it really isn't necessary until we actually run the particle systems themselves, right? So I feel like that should probably be something that's just done here because it's really not necessary for anything else, right? All right. So I think, yeah. So I think we're now down to sort of a much more simpler sort of structure for this code, which is good. We're getting better. And you can see that this allowed me to pull out a bunch of code into the upper level that used to be kind of sunk down in there. So now if you take a look at this almost as like of code injection almost, you can kind of see that between the begin and the end, we can now do a bunch of these things that only happen in the main visible update, and now none of those things, the particle systems, the debug rendering, the checking for joining players, none of those are welded into the update anymore, which means that now if we want to do a second update down here, right? Oops. If we want to do a second update down here, we don't really have to worry about all of those other aspects, right? So we can come in here and just call simulate, and just not pass these things in. Same as we were doing before. So I think we should still be getting now exactly the same results, right? Nothing has changed. Exactly like we wanted. And if we would like to have these things draw, well, I guess I don't have to do it that way. We still can. See? So that's really nice. And like I'm feeling better about how that's sort of starting to pull out. Now, what we want to look at here, again, like I said, is we just kind of want to take a little bit closer look at the stuff that we're doing in here, and now asking again, are there other things that we could do here? Is there other stuff that we should be being a little bit more careful about pulling out? So the first thing that I'd point out is if we take a look at mouse p, right, in update and render entities. So mouse p is really only used for debug picking and stuff like this. We could use some more water. So if we take a look at what happens with something like that, it's only there for debug purposes. And things that are only there for debug purposes oftentimes make a lot less sense to like structure your code around. So the fact that you have to pass input to something like this right now for mouse p doesn't make very much sense. So really the only thing that we should be looking at, I think, in terms of why input is getting past this at all, is in the execute brain side of things. So if you take a look at execute brain here, you can actually see why we need input. The reason is because input is currently getting used in execute brain for controlling the hero, right, for controlling any player-controlled character. So I'm not 100% certain that we really want that as our model for how controller input gets pushed down, right? We may want something that's going to allow us to do a little bit more thoughtful kind of an operation on this, where the brains pick up their data from someplace that isn't directly the input. That's probably going to be a better thing in the long run, especially so that we don't have input code kind of baked down in here in such a specific way. Now, I don't know that that's true. It's just a hunch. But you can kind of see that that's why input is flowing through here, right? Ignore this because this is just debug information, and we could choose to get that, to funnel that through in a number of different ways. In fact, I'm actually kind of curious about that. I want to take a look at that. So in update and render entities, what are we doing with the mouse P here exactly? So we do an unproject of the mouse P just in this one place. Is that correct? Yeah. So all we're doing right there is using it for hit testing an entity, right? That's what that's for. So again, that's also something that we might be able to, for like the debug UI enabled stuff, that might be something that makes a little more sense to kind of pull out separately. Because again, with something like where we're concerned about the performance, like I was saying, the reason not to loop over these entities again for performance reasons makes some sense, and we may not want to separate update and render. But for debug code, we know that debug code isn't even going to be shipping in the game, right? It's going to be disabled. So for that, it does seem like a pretty reasonable thing to say, okay, well, what if we just introduce a new function up here, which is like debug, debug entity, pick entities, something like that. What if we just introduce a new function up here for that and said, okay, let's loop through these entities just like we were doing before. But now, when we're doing this hit testing, maybe we pull that out. Although actually, now that I think about it too, can we just make this, well, I'm not sure yet. We may want there to be debug information that kind of gets output during this, is the only thing. Like, this, I would say let's pull this out completely, but I just don't know whether I think we want to sort of output debug information about this entity directly during this phase. That's a tough call. That's a tough call. I'm not sure how I feel about that. I'm not sure how I feel about that. Because in some sense, what we could do here is just say that the debug hit stuff and the like unproject or whatever, this could just be some kind of function like debug mouse, that the debug mouse position comes back and you don't have to pass it down, right? It could be totally a separate debug situation. So I don't really know how I feel about that. I think because our debug system is only so-so, like we don't have a ton of debug system in there, maybe let's go ahead and pull it out for now. So let's say that we pull out this one part right here, and we say that that's going to be something that we call externally like so. And then depending on which one of them we pick, let's see, I guess that's actually right here. Debug UI enabled, debug requested, there we go. And yeah. Just have one more thing to eliminate here. Debug begin data block. I'm curious to know, I guess we don't have to specify that we're ending a data block. I guess the only thing that has to happen there is just a regular end block, right? Which is this guy right here, I believe. So there's our begin block for entity physics, and there's our end block. There are no other things in here, so yeah, I think it's just this guy. Now, I'm not sure why that end block was there. Wouldn't that end block have to be after each one? Seems kind of broken, doesn't it? Like, I feel like the end block should correspond with this. But then again, the debug requested part, yeah, I'm not sure. Was this a spurious end block? Like, how did that get in there? There's the begin block, there's the begin block. There's only two, right? And similarly, there's only two end blocks. So I guess this doesn't really require an end block? I'm a little stumped by that, I have to admit. Oh, hi, I'm real smart. It's right there. Okay, so this would have to take the sim region. The entity debug ID only needs to be created once now that we merge those two code paths. We do need to have the render group and the mouse P passed in. And then the entity transform, I guess, is where we decided to put this entity. So this is a pretty good example, I guess, of why this would be tougher to put out here, right, in terms of knowing where this entity is. Because if we take a look at what has to happen for that to occur, you can see that, like, we've got this sort of relatively complicated piece of code that has to go on in order for the entity transform to be, set up properly. You can see that it needs, like, the cam rail ground Z and all that sort of stuff. So it's tough to say. We can keep it welded in there, but in the once we have sort of the 3D-ness of this working a little bit better, that's not going to be so hard to do. So it's kind of 6 of one, half dozen of the other, right? So what I will say here is, like, yeah, I don't know about this. That does suggest just looking what happens when it pulls out. Everything else is very simple. This is a little bit more complicated. We could pretty trivially reproduce it just by having there be a call here. But that gives me a relatively good argument for why I would want to keep this welded in, is just because if that does become complicated, I don't want to have to do it oftentimes, right? So let's see here if we can just kind of make this a single entity pick. And when we call through here, maybe we just pass the entity transform. Oops. Okay. We need to get rid of that, and then we're good. So yeah, so you can see debug pick entity now is something that will just pick a single entity, and that seems a little bit more tenable to me. So if we come through here and we look to say, okay, we're doing the render group, so assuming that we actually see this entity and we're processing it, we'll call debug pick entity on it so that it can be picked. And let's go ahead and, oops, pass the right parameters to it. We need the sim region, the entity, the render group, and the entity transform. Okay. So I think everything we need there is in good shape. But we still have this question of mouse P. Like I said, I kind of want to get rid of that. I don't think I want that to be hanging around. So what I'm thinking is, in general, inside our debug interface, we have sort of this ability to get information back from the system. And in fact, we see this in a number of ways, right? You can see here we look at global debug table edit event. So it'd be pretty trivial for us to use the global debug table to record this piece of information. So let me take a look at that. Here's the event that's being edited. We could pretty trivially in here say, here's the mouse P, right? Could just put that in there. And so if we wanted to do that, then it's a pretty straightforward process of just saying, well, anyone who wants to know what the debug mouse P is now can just get that from the debug system itself. So in here, when you say, I want debug mouse P, right? And you say, I want that piece of information, then you can just say, like, OK, that's just going to be equal to whatever the, let's see here, whatever the global debug table says the mouse P is. Something like that. And the equivalent. So that seems pretty reasonable to me. That doesn't seem like it would be causing anyone any particular harm or trouble. And we can, again, also make those not do anything when there is no debug information happening. So now we can keep those debug things into global variables. Again, the reason that I like that is just because I don't want the debug system and its additional needs impacting how the code is architected, given that the debug system itself gets compiled out when things are shipped. So I want to keep those separate and not creating that problem. So if we take a look at what we would need to do to support this now, we can say, like, oh, OK, we can generate this mouse P, and we can set that up. And then anyone who wants to get it can just get it by asking the debug system, right? And that's something I could set like way up here at the beginning too, if I wanted to. All right. So now we're out of the business of having to have this mouse P even exist at all, which is a good thing. Again, that's just a positive code change because it really had nothing to do with the actual code that was happening. It was strictly there as an artifact of the debug system, which I didn't want. So that's all good now too. However, I think that code was, I don't even know if we kept it up to date. It looks like we did because you can see it's still working now. So I guess we did keep it up to date. And I guess that was in simulation, right? Let's see. Yeah, so I guess that code all still works, and we can inspect entities properly, so that's good news. There's our hero. Look at him go. So that's all good. All right. So I think that's it for the first wave here of stuff that I want to do. And again, like that's getting a little bit cleaner, so that's good. I'm going to go ahead and go to the Q&A. And then we'll do a second 1-hour session after the Q&A. Just in case anyone has any questions about what we did. SF Gartner, can you try compiling with debug off? Yes. You mean just if we want to clean up our like things that may call this thing? I mean, I suppose one thing we should do potentially is if we want to be able to compile with debug off, right now we will need to have debug pick entity be blocked out entirely. Where'd that go? So, for example, here it is. This code right here doesn't, like, none of this wants to get compiled in, right? All of that wants to get compiled out. So we would want to do something like right. Other than that, I don't know that there's much that we'd have to do. So if we want to compile with debug off, it's that. And looks like that's it. So this has no debug in it. I also don't really remember, I'll be honest, if we've used this much at all. It looks like it's mostly just used for that one debug validation pass there. And the assertions. CTime stats, I know it's irrelevant for the code. Sure. You're talking about so I guess I don't ever remember this. I think I call them .ctime on my machine, and I must call them different things on this machine. Is it CTM? Okay, it's CTM. Great. Nice work, Casey. Handmade hero.ctm. Here are the stats at the moment. Do we have any Q's and A's? Not really. So I guess we can just start. ChaosCom says, what does the ... do in the define? And someone else asked about documentation in the code. So I can answer both of those. So the dot 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 and the define, even if you are an experienced C programmer, may surprise you slightly because it is actually new. So originally, and I guess I use the term originally a little bit loosely here, but originally, right, we have the concept of functions. I guess I'll just do like foo, right? Originally, we had the concept that we've got these functions and we specify the parameters of the function. So inside the parentheses, we put a list of all the things that we're going to pass. And we all know this. It's in every programming language, and it's fine. C++, I'm sorry, C++. C had a need sometimes for passing functions, parameters where you didn't know how many were going to be passed. And so typically what would happen is they introduced this notation of dot, 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 where you could have more parameters to functions. And we actually used this. So just to give a concrete example, if I was to compile this, this compiles just fine. However, if I was to write that, it would say it doesn't work, right? But if I said, well, you can accept as many arguments as you want, now I can pass however many things I want to it, and it will work, right? So the dot, dot, dot in C for decades has always meant just this function can support as many arguments as the caller wishes to pass it, and it's assumed that inside the function, I am going to deal with parsing those arguments out somehow. It's up to me how I do it, but that's the idea, right? Well, C, of course, also had the ability to do macros, right? And they worked pretty much the same way. I could say foo of bar, and then I would call something where I would say, OK, I want to call my macro. And it would work. But if I tried to pass more parameters to the macro, it wouldn't work, right? Exactly analogous to the function. But for the longest time, there was no way to do anything about that if you wanted to support multiple arbitrary numbers of parameters in a function without specifying how many there were supposed to be. You didn't have any option of doing it. Dot, dot, dot syntax did not work in macros. Well, recently, they expanded the notion of macros. Recently. It's not that recent, I guess. To allow exactly that same thing. The dot, dot, dot just says you can put as many additional parameters as you want at the end of this macro, and they will be accepted. What you can then do, much like how the function is expected to deal with the extra parameters, the macro is expected to deal with those extra parameters. The way that it works is anywhere in the expansion of the macro, right? The macro expansion would go here somewhere, right? You can put the term vargs, like so, and it will put the entire contents of whatever the dot, dot, dot represented. So in this case, the 4, comma, the 3. It will put that in place of the vargs. So example of that would be if I was going to say, let's say I did something like this. Here I'm going to add 3 numbers together. And so I have my result, right? And in this case, I want to be able to add these 3 numbers. Well, I have bar here, and I say add 3 numbers, and I pass the result of this macro. This macro is going to get expanded contextually before the file is compiled. And what it's going to do is it's just going to evaluate to 5, right? It's just going to be evaluated to bar, right? And that's not enough because we need 3 parameters, the A, the B, and the C. Well, if I was to say, oh, also expand the rest of the things that you got passed, you can see that now it works because now this is getting expanded to 5, 4, 3. Similarly, if I was to pass more parameters here, it would then again complain that I had too many arguments to my function, right? So that's all the dot, dot, dot is. It's really just an equivalent to the dot, dot, dot syntax for functions, but this way it works for macros. Now, the nice fringe benefit of this. There are a number of reasons why that's really nice. It means, for example, that a function like a very standard function such as printf, right? Printf looks like this. So if you wanted to make a macro that called printf, you couldn't do it before, right? Because you had no way of telling the compiler, I want to take as many arguments to my macros as possible, right? Now you can. Now, if you want to, you can make something that thunks through to printf and will work. And that's very nice for completeness, right? So it's very good that they added this. So that's a nice aspect of it, but also an additional aspect of it that's really nice is when you have debug functions, right? When you have a function that macro that's being used for debug purposes, oftentimes what it looks like, in fact, we can even use the printf example. Let's say we want debug print, okay? And all debug print is going to do is it's going to call printf. But I want a way to turn it off. I want a way to compile it out of my code. Well, now I can say, like, OK, you know what? I wanted to use a slightly different example. Let's say I do something slightly different because it makes a little more sense with what it's more congruent to the case that I used it in today. So I think it would be a better example. Let's suppose that I make a thing that's like debug print integer, right? And so I'm just going to pass the int here, whatever it is, and then I'm going to call printf. And I'm going to say like debug, d, right? And here I am printing out my integer. Okay? So I'm going to call debug print integer in my code, and I want that to print out the integer. But I only want to do it if we're in like debug mode, right? So if someone has pound-defined the symbol debug, then I want to do it. But if not, then I don't. In the old days, what you had to do was you had to say this, right? So now I have debug print integer, and it takes an integer, and it does the print. Then I have debug print integer that takes an int. In the else clause, meaning if the debug symbol wasn't defined, I'm going to make it expand to nothing. So it doesn't affect my code at all. Well, the bummer about this is you can imagine you started to have a lot of these things oftentimes, right? So there's integer and real and blah, 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 right? There's just all these functions here, right? So typically what you had to do when you were trying to do this switch on and off thing is you then had to like cut and paste them all and do this, right? And that's bad enough. And unfortunately, we really haven't fixed that in the language yet, but what are you going to do? But the insult to the injury is once you have it set up this way, now what happens if you decide that this thing needs to take another parameter? Well, now you always have to go down and change the corresponding version to do the same. And what's worse is because this is only a compile time directive, it means that until you actually compile it without the debug flag set, you'll never even get an error. So you don't even know you broke the code. You don't even know that you broke the non-debug build until you actually go build it. So what's much more preferable to do now, just as a general coding convention that helps save you some time, is that when you call debug print, when you define the debug print macro for the non-debug case, just go ahead and don't specify the parameters. Just put the dot, dot, dot in there. Because you don't care what those parameters are. The whole code is being compiled out. And so this way, you can basically just say, oh, no matter what the changes are that happen up here, as long as the function names don't change, I'm fine. So it kind of helps eliminate a few steps to that process and just saves you maintenance time, which is always good. Hold on a second. Okay, so another question is, how about documentation? I see you don't have too much comments in your code. And yes, that's true. I tend to frown on comments. I don't think they're a very good programming practice. And the reason for that is because I find that comments are almost always wrong. as programmers, I think that sort of an underappreciated thing is if you're a very productive programmer, some programmers aren't very productive, and maybe for programmers who aren't very productive, comments is a different story, right? But if you're a very productive programmer, then one of the problems that you have is that you're leaning on the compiler a lot to make sure that when you have a piece of code that it actually semantically checks out, right? So you're very used to using that process and also tests, right? Like, maybe you practice test-driven development, or maybe you have a way of testing your code, and you run that. And that's how you're ensuring that the code that you're making is working and is correct. We have no such thing for comments, right? The only thing that we have to try and verify the accuracy of comments are like code reviews, and code reviews are they're very time-consuming. They cost a lot in terms of productivity, and they don't even necessarily verify that the comments are actually right. It's sort of just a maybe they do, maybe they don't. So that I find that comments are just usually a pretty bad idea. A comment oftentimes hurts the programmer coming down the pipe after you more than they help, because they send them in the wrong direction, right? For every correct comment that survives in your code, there's probably an incorrect comment. And even one incorrect comment out of every 10 is enough to really make it hard for somebody who's relying on the comments to do their job effectively. So I say comments usually bad idea. Try to keep the code as readable as possible, and restrict your use of comments to when you're done with code. When you're finished with a piece of code and you're not going to touch it for a long time, that's usually the time to put in a comment. So when we ship pieces of Handmade Hero and we're like, we're done with this, we're not going to touch it anymore, that's the time to put a comment in the code, because then I know that that comment at least has a really good chance of actually helping someone more than it hurts, because I'm writing it at a time when I'm pretty sure I'm not going to change the overall architecture. And furthermore, those comments should usually be about exactly that. They should be about the overall architecture. Because again, the code's going to get debugged slightly and maybe make slight modifications over time. I don't want to put these bad comments in code that are going to live longer than the code they're describing and become erroneous. So what I try to do is I try to restrict myself to those kinds of comments. And as such, you won't see very many on Handmade Hero till the end. I sometimes receive comments from colleagues during code reviews that I should put long pieces of code into functions for cleanliness. What parameters goes into your thought process when deciding if a piece of code should be placed under, under a function? How do you make the decision? Well, usually when putting something in a function for me is about whether it's going to get called more than once, right? I don't think that pulling code out of a function and putting it into another function increases the cleanliness in any, in any real way. It's really just an arbitrary decision, and it might make it more legible for some people, but it might make it less legible for others. So I would say, typically speaking, your decision whether you pull something out into a function should be, do I need to call this in more than one place? That's usually really all that it boils down to, if that makes sense. So I don't think there's really a lot more to it than that. If all of your colleagues are uniformly, if literally everyone you work with really did have a better time reading code that was pulled out into smaller functions, then if you can actually verify that they're not just saying that and that they really do have an easier time reading it. Because one of the problems with programmers a lot of times is that they say things but they're not true, right? For example, people oftentimes will say like, oh, you gotta put this thing in a class or something, right? But they have no actual reason for that. They think that clean code means putting things in a class. but they've never done any research or provided any data that backs up that claim. So a lot of times it becomes problematic if you're going based on those assumptions. So if colleagues are telling you to do something and you suspect that that's why, meaning it's just because they've been told this and they never really thought it through, that's usually a poor reason to do it. But let's say you were in a situation where your colleagues really legitimately, for whatever reason, the way their brains tend to work is that they like reading small functions and can understand them better. If that turns out to be true in some measurable way, then that's obviously a good reason to do it. It doesn't mean your code is bad if you didn't do it, and it doesn't mean that it's always best to break things up into small functions. All it means is, hey, you're clearly in a work environment where it benefits your colleagues to do this thing, so that's a perfectly reasonable reason to do it, right? Hopefully that's true just in general, right? It's like if there's some particular coding practice that perhaps has absolutely no basis or no fundamental reason why it's better, you may still want to do that practice if it does in practice make your specific team function better. Because every team and every development environment is going to be different, sometimes drastically, sometimes only subtly. But if you can establish that it is definitely true for your work environment that a certain coding practice helps people, that is a very good reason to do it. And the only thing to be sure about, obviously, is that you've actually come to that decision in a data-oriented way, where you've actually tried to do some experiments to determine that it was not just somebody's arbitrary, fanciful notion that this was better code. So. I think, have I got all the questions? I don't see any other questions. So I think we're good. I don't see any other questions. If there were no other questions, I'll start the second block. How much code is debug code versus real code? Well, it's always hard to say. It changes a lot from project to project, right? The breakdown on Handmade Hero is probably, I don't know, 30% debug code, 70% actual code. I don't know. I actually don't know. We haven't measured it, so that's a complete guess on my part. I wish there was an easier way to tell. You can obviously get a clock count on the debug code versus the non-debug code because we have these functions here. These files here, debug. They're only debug code, but there's debug code scattered throughout these other things, and so even that clock count would not be definitive. Yeah, that's a good point. Uplift Coder suggests that you could expand the files and take the diffs of the pre-processed files in both cases, one with the debug on and one with the debug off. That would totally work, I think. Well, not even that doesn't really work because you need to pre-process. The preprocessor would expand out things potentially that would skew that metric a little bit. But yeah, that's probably the best. That's probably the most accurate one we could hope for at the moment. All right, let's go ahead and get ourselves back to normal state so we can start again. All right. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. This is our second block of our 2 Saturday blocks. In our first block today, we were just showing how to pull apart a piece of code that did a bunch of different things, where we wanted a little bit more control over which things happened and which ones didn't. And in the second block here today, I'm going to kind of go back into that a little bit and just kind of comb over that code and do a little bit more restructuring of it till I'm a little bit happier with how everything in it is working. So yeah, it's the phrase day should probably always have been hour. Unfortunately, I don't know, maybe I'll change it to hour instead. But here on hour 350, you want to start with hour 349's source code because that's what I'm was starting with. Is that correct? That's not correct. That's not correct at all. There we go. There we go. That's what we actually wanted. Boy, I don't even know how to use my own little device thing. I probably will have to update the timer to deal with the 2-block system. So what I meant to say is today's day 351, or hour 351 as it is. So you're going to want to use hour 350 source code. That's what we're starting with today. All right. Let's go ahead and jump back into it here. Mr. Timer will, I guess we're getting an extra 5 minutes here. You know, sometimes we get an extra 5 minutes. It's always good. The timer giveth and the timer taketh away. So let's jump back in here and take a look at where we were. If you remember, I was dealing with this code in world mode, and we kind of did a nice transform on the code here, I think, because you can kind of see like here's the code for simulating a region, a non-primary region of the world. Even including rendering, it's kind of nice. It looks pretty clean here, right? And here's the code for simulating a primary region, or I should say the primary region. And you can see that it does some additional things, right? It does check for joining players. It does this sort of frame-to-frame delta that gets used for doing the particle systems. It does some debug rendering here. And these are fundamentally doing the exact same things, right? But because we broke it up into begin sim, simulate, and end sim, it now allows us to insert in this case where we're talking about the primary region. It allows us to insert this additional stuff in the right places without having to duplicate the code, right? So that's kind of nice. So that's pretty good, and what that means is that now if we wanted to, we could actually distribute the work of updating the world, the part of the world that's not the main part we're looking at. We could actually farm that off to many threads if we wanted to, right? So on a typical 4-core computer where maybe we have 8 total logical processors to deal with, you could imagine us farming off the update step and having it be 8 times faster, right? Probably won't get a full 8 times faster, but the potential win obviously is there. And right now we have a very highly unoptimized function that's being called in there. Especially in debug mode, you can see it takes a long, long time, right? It's called get closest traversable, and you can see that it's way up there in terms of amount of time it takes out of the frame. Now, granted, if we do compile in release mode, that kind of goes away. So it's a bit of a red herring because even though it's a function that we really should optimize, because it's doing a very, very poor job of what it needs to do right now. When we do compile in release mode, you can see that it actually ends up being a non-issue. It's down here in the 2% range. So even though it's awful, it's still not that awful. But we can cheat because if we want to see how we're doing here, like I said, if we just leave ourselves in debug mode, we have a really highly unoptimized function that can kind of stands in, if you will, for doing more heavyweight updating in here potentially. So we already have a thing where in debug mode, we're not able to hit 60 frames a second in debug mode. We're hitting it easily in optimized mode, but we're not able to hit it here because of that unoptimized function. What we can do is say, let's use that fact that we've got a piglet in there, right? In fact, maybe I'll put the hat on. Let's use that little piggy to sort of help us figure out whether we can get some time back here by doing sort of distribution across multiple threads, right? And so what I want to do is I want to use this as a motivation for us to get the code into a place where we can run multiple simulations on multiple threads if we want to. I'm not saying we need to do that. I'm saying that's something I want to make sure this code could do so that if we start to crank up our simulation complexity and we want to be simulating lots of different parts of the world at the same time, we can leverage multiple cores of the CPU to do exactly that. All right. So I'm going to call this one first, and I'm going to call it without any of the, so we're going to use this style simulate, right? The kind that doesn't actually draw anything. Okay? I'm going to go ahead and wrap these guys a little bit, like so. So this is the isolated piece of code that we know we care about for simulating a non-primary region of the world. And now I don't want to tax your memories too much here. I realize that on Handmade here at this point we've shown how to write so many things. I love how much stuff we were able to show how to write in a game engine so far. It's awesome, but it does mean that I do ask a lot of people to try and remember the things that you've already done. So I apologize for digging back like that. But if you remember inside, I didn't want that file. If you remember inside our renderer, we have this sort of concept of multi-threading. And I don't know if you remember how we did that, but essentially what we did is we have these work units that we divide things into, and then we have threads that come along and pick them up and do them, right? And you can actually see this working right here. This is the code for it. So we have a tiled renderer, and you can see here it loops over the tiles in X and Y, however many there are, and we can control those parameters. And then it creates a little work order here that says, I need you to render this tile. And this doTiledRenderWork function would actually be the function that would do the work. And so instead of doing that, what we do is we just push it on a queue and say, this is work that's available to do. And then we trust that our multi-threaded code will come through, pick up those work things, and do them. And then what we do is we say complete all work on the thread that launches all these. And what that function will do is it will just go look at that queue and keep doing work itself out of that queue until it sees that all the work has been done, right? So this is a very, very simple way of doing multi-threaded work distribution, but it works actually very well for a lot of circumstances, and we can just keep leveraging it. So if we take a look at what we want to do here, what we want to do is look at the doTiled render work function and go, can we go ahead and make an equivalent function to that that we can use for doing this simulation step? And here's our function prototype for it, and we can call this do world sim or something like that. We can time it, of course, like we always do, so we can see how much time it's taking. And then we can go here and just imagine what we would need in terms of one of those little work descriptions in order to make this happen. Now, usually, like I said, this is a very straightforward process because we should be able to see exactly what we need just by looking at the operation we're talking about. And here you can see, this is what we know we need because this is what we were calling before. And you can see here we need a boundary, right? So we need to know where we are going to simulate. We need to know some information about the world, such as the transient state, the world mode structure we're working on, the DT we're trying to simulate, and then we need to know some rendering information. And that rendering information, thankfully, I believe, can all be blacked out. So we can just get rid of it and not have to worry about it, right? OK. So that won't be very hard to package up. But you can see kind of right off the bat that we have a little bit of an issue. And maybe I'm cheating when I say you can see, because, again, I'm the person who's supposed to be teaching programming on this stream. Let's just say I can see, and probably the experienced programmers out there who watch the stream can see, that we're going to run into some problems. But it may not be obvious to some of the beginners out there what the problems are going to be. Well, in a multi-threaded environment, the problem is you can't be doing anything where two people can't do it at once, right? And so if you take a look at what's going to happen here, the instant we call begin sim, you can see that it's going to use this transient arena to create the temporary memory it needs in order for doing the world simulation. That's just fundamentally not going to work. The reason that's not going to work is because the arena is a single-threaded construct, right? If we take a look here at how we wrote the memory arena, nothing in the memory arena does any kind of locking or prevention of contention for resources. So when we do something like call allocate on the arena, it is not locked, right? There is nothing that would prevent two threads from accidentally stomping on each other's allocations or corrupting the state of the memory arena because they're modifying different values at the same time without awareness of each other. So that's a problem, but it's a problem we've seen before. We already have the notion that temporary memory for a work job can come from the job itself. And we know that this is true because we actually created this when we did that the work with the transient state originally. What we did, that's not the file I wanted. There we go. What we did is we said, OK, when we have these tasks, they have their own memory arena in the first place, right? Every task has an arena it can sub-allocate out of, and it's aware that it is the only person accessing that arena. So it doesn't have to worry about that contention. So what we need to do first in order to put ourselves in a position where we can start to make this code thread safe is we have to get rid of that cross-dependency. So that's really, really easy. All we have to do, we're lucky, all we have to do in this case is stop thinking about the temporary memory part with the begin temp, end temp stuff here as coming from the transient state, and instead just say it has to come from an arena that you're going to pass in. And so that way, when we're calling it from the external code in the mainline block, we can pass in the transient state arena if that's the arena we want to use. But if we're calling it from one of our tasks, then we can just pass in the task arena. Right? So here I'm going to get rid of that and pass the temp arena in. Same thing here, temp arena. And now the trans state is illuminated. Right? That is not something that's allowed to get passed into that function at all, and no one's allowed to use it in any way. So that should help us out tremendously with starting to make this code something that can be called from multiple threads. So here, when we come through, I'm going to go ahead and call the task arena there. I don't fully remember the task with memory situation. I don't, to be honest with you, remember very much about how this gets called back exactly. I suppose that's just something that gets isolated. Let's take a look. I don't remember exactly how the begin task with memory, end task with memory system was supposed to work. You can see here we call it, and then we end, and it looks like it's just, oh, so it's just, I guess all that's really happening here is you just use this when you're initially farming off the tasks, and then you can be assured that they have them, right? And that's really it. So yeah, this, I feel like this is something that could probably get expanded and put into the platform side of things now. It seems to me like maybe this is not such a useful construct anymore, especially that now that arenas are things that can be sort of allocated from separately. So I'm kind of a little bit wondering about that. Let's take a brief detour here, because I want to double check that that's really the way that I want to do that. So what I'm going to do is I'm going to put this on hold for 1 second. And we know that we can still fulfill our previous obligations to pass things by passing in the transient arena here, right? So our game still runs just fine, and it's working off of the transient arena by passing it in. Same basic idea. What I want to do now is I want to look to see, is anyone using this system anymore? Because originally it was used for some rendering purposes, but it's not being used for that anymore. The software renderer doesn't need memory, I don't think. Maybe it does? I can't remember. But I don't think it does. So I want to take a look here and see if anyone's even using begin task with memory, just so I can be sure. So it looks like the people who are using that are in the asset system. So here you go. You can see us trying to get begin task with memory, and it's operating off of the transient state there, right? So again, this just doesn't seem to be a smart way to do this for a number of reasons. I understand why we did it this way originally. It's because we wanted to keep this in the platform independent part, and because memory arenas worked in a very specific way. We've expanded our concept of memory arenas now to allow things like having them be acknowledged by the platform layer and work with the platform layer. And so at that point, it seems to me that this is not particularly smart necessarily, right? So I want to see, before I say anything about it, let me just see exactly what is happening here in terms of how memory is being allocated. I want to see how it's doing. Yeah, so this is roughly as I expected. So if you take a look at what happens here, you can see that really, in terms of allocations, there's not really any allocations that are going on besides that asset work structure there, right? It's just the task itself that's getting pushed on there. And then what the memory is actually used for, I would assume, is actually in here, right? So when I come through here and I'm going to do work, it's only really in here, I guess, that anything would actually be getting used for the arena. In fact, now that I look at it, is anything even being used there? So I guess even the thing that I was going to say about why you might want a little bit of this doesn't really seem to be true. So yeah, if you look at what's happening here, really, this is just not necessary. Like, why are these things? This is just not the way to do these. Okay. I think I need to take a brief moment and explain why I don't think that's a very constructive way to structure that. So let's go ahead and go to Milton here and see if we can't get this going. Let's see. Milton. I think we don't have a working Milton with the hardware renderer, right? Yeah, so we're on this one. Okay. So let me talk for a second about what I mean here and and we'll see. I also don't know, are we actually, so I don't know if we're getting any tablet stuff here, are we? Looks like grip pen all, so the tablet's working now. Is Milton able to recognize the tablet? I'm not sure. But hopefully yes. There we go. Okay. Because we were having problems, my tablet kind of conked out, but now it's fine. All right, pretend that's not there. Here we go, day 351. Right? Okay. So let's talk about memory and multiple threads. So if you look at the way that we're doing it right now in terms of memory and threading, there's kind of two ways you can look at how memory travels through threaded code, right? And what I want to do is kind of encourage you to think about two sort of separate axes that are sort of happening here. One is like the task, right? So we may have tasks like A, B, C, D, right? And these are actually things that get queued up, and there can be any number of these, right? There's an arbitrary number of tasks that can get queued up. And then there's threads, right? There's thread 0, 1, 2, 3, right? And here there are as many as there are cores, really, logical cores. We don't really want to make lots of threads that are not corresponding to anything physical. We want to roughly have the same number of threads as we have physical cores logical cores to do work. And so we have some number of these, and it is not arbitrary. It is not based on the amount of work. It's based on the number of workers, right? So this is based on like work, and this is based on workers. Now memory for these two sets of things is exactly the same sort of thing, right? There's memory that might be used relative to the work that's being done for the lifetime of the work. And then there's memory that might be used relevant to the lifetime of the worker. Okay? So, for example, scratch memory, meaning memory that is only used during computation, is really just memory that's proportional to the worker. Each thread needs its own scratch memory for doing work, but that memory doesn't need to persist outside of the thread having done that work, right? So let's say that task A has 3 parts to it, right? There's the setup, there's the work, and there's the completion, right? And this part right here is done by the main thread, right? The thread that's actually creating these tasks to do is the one that's doing the setup. The work is being done by one of these worker threads, right? Maybe it's happening up here. So here's the work, right? And maybe the main thread or something did the setup. Here's the setup. And then the completion is maybe picked up somewhere else by the main thread, right? And the main thread during this time would be doing other things. So we come through here, we do some setup work. We now have the work is queued. Eventually, some other core picks up the work and does the work. And then later, we look and find that the work has been done, right? So if we only need memory during this work part, and we don't need it to persist from setup through work and into completion, then really what we want is scratch memory. We just want memory that we use just for a given thread. And each of these threads can have its own scratch memory, and they never need to talk to each other, right? On the other hand, if we do have memory that needs to flow this way, it needs to be there for setup, there for work, and there for completion, then we have task-oriented or work-oriented memory. And that needs to be managed per task. So what we're doing right now is we're doing memory per task, right? You can see that we have some number of tasks that we allow here. Each one of these tasks has an arena, and the memory for that task comes from that arena. That makes a lot of sense if we're actually doing something that looks that way. But at the moment, we're not even doing anything that looks that way. So that raises the question of, do we want to keep doing this or don't we? There's a certain flexibility that comes with having each task have its own memory, certainly. So it's not a given that we shouldn't keep it that way. But what I will say is, even if we wanted to keep it that way, it does seem like a poor choice to have it be some kind of a locked block set of structures. We probably want to allow us to create as many of them as we want to, right? That's probably my best guess there. Or at least have it be proportional to the number of things we actually expect to queue in practice, right? So yeah. So that to me is kind of a little bit of a red flag there, right? And it just seems like something where I probably don't want to be using that kind of a system in cases where I don't want to do that. Whether I should remove it from the asset system, I'm not sure yet. It looks like I probably should because it really just doesn't look relevant. But what's definitely true is I don't think I would want to do it here. So probably what I'd want to do here is I would want to have my memory arena exist only for the lifetime of the work, right? And so what I'd probably want to do here is say something like, where is it? Here. I would probably want to say, hey, let's make a memory arena. And then when we're done, we'll just eliminate the whole memory arena. So that way it doesn't, you know, the memory itself is coming totally from inside this safe area, right? It doesn't have to do, anything else. It doesn't have to talk to anyone. It's like just coming from its own entirely isolated arena. And it will do allocation as necessary to get there. Now, I'm going to put a to-do here. And what I mean by this comment, or to-do, I should say, is that we don't actually want to allocate new memory blocks every time. Every time we would open up a world sim here using this threaded method, we will have to call the operating system to do a virtual allocation to get us a block of memory to work with, and then at the end we'll have to re-release it. There's no reason to do that. We might as well have each worker thread just have a block that it's virtually allocated from, and then have the arena just use that block. And only if we overflow the block would we ever have to call anything else. So probably we want each worker thread to just have an arena it uses for scratch space, and we'd pass it in. That's a much more efficient way to do this, and it's something that we should probably do after we finish what we're doing right now. So inside do world sim, you can see that we can now sort of work on the rest of the part that we care about here. During tiled render work here, where we're doing this this call to get the data out, what we want to do is replace that with our own sort of description of work that makes sense for this. So this is like world sim work or whatever. So we have this concept of world sim work. That's going to be the struct that we need to create in order to create a work order for this kind of operation. We know that we need the bounds of the simulation, so where it is going to simulate. We know that we need the world mode structure, right? Or world mode, what is it? Game mode world. We know that we need the DT. Yeah, I guess at the moment we still need the game state as well. And again, some of these things I think we can start to get rid of. But if we look at what happens there, now we can sort of say, like, okay, we know we can get the world mode and the sim bounds and the DT out of the work order. So we will. That allows us to call this properly. Oops. Nice typing there. Hand is tired. And then the game state. There we And that gives us all the stuff that we need. So now when we call one of these, we know that we can encapsulate all the stuff that we need into one of these work orders so that that's all it needs to do one of its world simulation steps. So if I want to kick one of these off now, I can do it the exact same way that we were doing it inside the renderer. So you can see here how we do it. We create one of these work orders, right? And then we kick it off. So if we want to do this in the update and render world call, where we want to do a bunch of simulations here, let's say right here, what we can do is do a for I loop and do things exactly the same way. We don't really know at this point because we're kind of making this up as we go along, since we don't really have the need to simulate other parts of the world right now. But let's suppose that we did have some idea of how many of these things there were going to be. So we would say something like, OK, there's the world sim work. And these are like the some number of them, 16 parts of the world that want simulation, let's say. And then we can say, OK, sim index equals 0. Sim index is less than however many of these things we wanted to do. We increment it. And then we fill out the structure that we were trying to fill out. Now notice this is, exactly analogous. It's literally a tiled renderer for the world, except instead of rendering, we're simulating, right? That's all we're doing. And so in order to do that, what we need is some way here of going like, OK, we need to know where we're sort of going to say that this happens. Let me go ahead and pull our work order out to the H file so it's a little easier for me to look at. There it is. So I know I have to set the sim bounds. I need to say, like, here's a place that you're going to simulate. I know I need to sort of pass in the parameters that it's going to need to operate. But other than that, I'm pretty good to go, right? And then just like before, I'm going to do exactly the same thing where we do add entry in the multi-threaded path. And this is going to be do sim, or sim world work. I don't know what I called that. Forgot. Do world sim. And in the other case, we're just going to actually call it directly, right? Now, we need a queue for this to happen on. And I believe we have that already in the transient state. It's just the high priority queue, because this is the work that happens immediately. So all we really have to do here is just let it go. Right. OK, so in terms of where we're going to have the world simulate, it doesn't really matter where we have this done, because we're just doing the simulation as a test. But we need it to be in different places. So in order for this to make sense, I need just some notion of how to displace these sim bounds. And so much like we were doing before, I probably just need to pick random places displaced from where the camera is to do the simulation. So what I could do here is I could say something like this. And then I could do another one. I could do, like I said, kind of a literally tiled render thing, like so. In this case, let's just say that we were going to do simulation of the world, sort of, I don't know, offset from the camera a little bit. So we just say like offset x equals whatever the sim x is, and offset y equals whatever the sim y is. We just need some way of kind of displacing these things around. And so I don't really remember what sorts of displacement we used for the original sim bounds here, but let's say that we're just going to displace it by maybe 100 each time or something like that. So we could just say like times 100f and leave it at that. So that's our displacement that we would use, and that way we could say like offset. I don't really remember exactly how this works, but offset the sim bounds here. And I guess I just passed that in. So that just gives me some rectangle to simulate that's not the main one that we're looking at, right? And that's really all I have to do to set up this thing in exactly the same way as the previous render. And now we should be calling that function a ton of times. That, of course, should hit our profile really heavily. And yeah, you can kind of see like just a lot of debug events basically being generated by that is mostly what we're spending our time on. But now we're actually sort of simulating all of those, right? Now, unfortunately, we can't see any of them simulate, which is unfortunate, because if we come out here, none of them are going to be rendering. That's intentional, right? So we might have to add some calls to actually do rendering of these things in order to validate that they're actually being simulated, but at least we now know that we're roughly sort of calling through here. So when we do this simulation, I guess our world doesn't really extend in this direction either, so I do wonder if maybe this would be smarter. That should also make it take a lot more time, because we now should be actually hitting we should be hitting more parts of the world that actually do stuff, right? And you can see like a lot of these calls now occurring. All right. So we're still calling this in a single-threaded fashion, right? I have this if 0 going here. But all it takes for me to now call this in a multi-threaded fashion is to change that to an if 1, right? And what on earth did I just do? Oh, there we go. I'm like, that end if was in the wrong place. All right, there we go. And now we will actually have multiple threads doing the simulation at the same time. It's not going to work correctly for some reasons that you'll see in a second, but we've at least set up the structure properly. First question is, well, why doesn't it work? The reason is because now we have multiple threads working on the world sim, but some of those data structures that they use are shared, right? And when you have multiple threads working on shared data structures, you cannot just let them do their thing. Even if the language that you're using or the system that you're using has locking built into it for you at the lower level, you're not going to guarantee that your operations are doing the correct thing if you haven't thought through how those threads actually need to interact. And since we're writing low-level code here, we'll just get straight up crashes if we don't do something smart about making sure that our code thinks about who's doing what and when. All right. So let's start with some of the basics. If I was to go over to the sim region code, hopefully you can see that it's already set up in a good way for actually doing the right thing here. The way that it works, you can kind of see, is it goes through the world and it unpacks all the entities into its own working set. Then it will do a bunch of work on them, and then it will pack them back, right? The nice part about this is it means that the place where we actually are sort of working with the shared data structure that is the world is isolated to the pack and unpack steps, right? So we don't actually need to talk to anyone else during the actual simulation. So during the pack and unpack, we do. During the simulation, we don't. Okay? Because the world data structure is shared. All of the simulation stuff needs to unpack from the world and then pack into the world. And so we need to make sure that they synchronize their doing of this. But once everything is unpacked, we should be even in a situation where all the simulation just happens internal to that system. All right, so there's some things I want to look at first. So what I want to do first is I want to take a look at our simulation call. I want to know why our simulation call requires the world mode, right? I want to know, for example, what in brains requires it. Like what are we doing with the world mode, and why, okay? So what you can see here is the only reason that we're passing the world mode at all is because we want a source of entropy, right? We want something in the system that gives us a random number source that we can use to progress. Now, I don't really care about that random number being synchronized across threads. All the threads could use their own random number generator, and that's just fine with me. So what that means to me is that really this world mode is probably not a good thing to pass to execute brain. Really just the source of entropy should be passed to execute brain. And then we can break that out and not worry about that structure in terms of having to lock it across accessors, right? So let's put that like on the list just for a second mentally. And then the other thing I want to do is now I want to see why was world mode getting passed here, right, to update and render entities. So you can see that it's accessing some kind of constant. It's accessing the particle cache. And then it's used in move entity, which I don't actually know why. So here we are in world mode, in move entity, looking at world mode. And so it looks like the only thing that that's used for is sort of the per entity collision suppression, right? You can see that there's this sort of like collision rule hash thing that's being used to look stuff up, and the can collide is that's where that's coming from, right? So we don't really need that hash anymore. I don't even know if we're using that hash anymore. And there's a good reason not to use it, which is that it does sort of lock people up if we have these pairwise rules that can be changed over time. So that does sort of give us a good reason to step away from that, which maybe we hadn't had before. So let's take a look and just see what happens if we get rid of it. As expected, that sort of piece of code wants it, but add collision rule is probably the only thing that we really need to know about. Where are people calling add collision rule? And the answer is nobody is calling add collision rule. Good. So let's get rid of it. It's gone. All gone. There we go. And now that world mode simply doesn't have to be passed anymore to the move entity call in any way. So if I take a look at move entity here and I get rid of world mode, I should be able to just eliminate it entirely because now can collide won't need it. Because it can be done directly, and presumably handle collision, same thing. Okay. So again, getting better. Looking at here, we're just reading some of these out. And so if you take a look at what we're looking at here in terms of meaningful changes, it's really the particle cache that's important. Typical floor height is here for a number of reasons that probably we are going to want to step away from a little bit. And so I'm OK with leaving that in temporarily, but we can probably eliminate world mode from this altogether, and that would be great. And I think the thing that we can do here is just say, let's go ahead and pass the particle cache in. And then we can just say when the particle cache is not set to anything, then we won't add particles. And so if I take a look at the particle code itself here, when we have something like spawn fire, I'm just going to predicate these so that they don't actually do anything when you pass in a null particle system. That way we should be able to prevent that from happening entirely, right? Okay. So again, getting closer, getting much closer to what I want this code to look like. It's little tiny baby steps, always little tiny baby steps, and they, are constantly trying to guide us towards what we want, right? So this doesn't need world mode either. So yeah, what we want to do here is just say, all right, update. When we're doing our update here, we want to pass in that particle cache, and I guess I don't know why that gets passed to begin world change either. Let's take a look at that. So that's a vestige of when we used to unpack particle systems, so that can get removed too, which is great. Again, keeps getting better and better. Oops. Here we go. So now we're just down to needing to pass the particle cache again in here. And when we're actually doing simulate, that's actually something we do want to pass in. And so I guess what I'd say there is, again, let's pass it in here. Since it is optional, keep it down in here. Oops. And I don't really remember where we passed it here, but let's go there. So it's right before. Go. And now we just have to pass it. So in here, we won't pass a particle cache, right? We're just not going to pass one because it's not going to get used. And then in here, we will. Right? So in theory, we should still be working properly, and we still should be. Oops. I forgot I said still be working properly. What I meant was if we go to here. And we should still be having particles spawned, which we are, which is good, right? And so that's all well and good. And so now we're just a little bit closer to having everything being respectful of the data on either side. Okay, so jumping back here though to it, where we have our simulate call, like I said, world mode is still getting passed around. And it really doesn't need to be in a lot of situations. The floor height needs to come through here, but in execute brain, it really doesn't need to have that happen. So at the very least, inside execute brain, what I probably should do is pass a random series here that's like entropy, right? And this is where the entropy comes from for brain simulation. And it shouldn't really care where you got that from. Like maybe you wanted the entropy from somewhere, maybe you didn't, who cares? It's just not that relevant. And to the brain code, it just knows it needs a source of entropy, and it wants you to provide one, but it shouldn't matter beyond that where it comes from. So when you call this, we can say game entropy here, and then we're good to go. So again, now we've almost gotten rid of the world mode stuff entirely. Inside Handmade, inside Handmade entity, if we take a look at where that's being used, it's just the typical floor height now that's ever actually getting used. And so we could even just for now, just again to sort of get us closer to where we want to be, say, all right, until we get rid of that typical floor height, we're just going to pass in the typical floor height directly, right? And it's not great because we probably want to systemically deal with this in a much more logical way after we do the 3D move. But for now, whatever, right? So now we're much, much closer, because now world mode is not really even getting used for the most part in here. It's really just a guidance for a very small piece of information like the entropy and the floor height. It's only two things, so we'll be able to pull those out really easily as we kind of go further in. But now the question is, well, okay, what about the other times when we were passing in this world mode? So if you take a look at world mode here, right, you can see that in this case, it's probably very necessary if we're talking about the camera P situation. And in fact, you can see here, we really want to abstract this part out anyway, because the camera stuff. So really, this camera P stuff, we're probably going to have to deal with outside of this anyway, because the camera P is only relevant to one of the sim regions. So that we could probably pull out pretty easily. So all I really need to look at here to keep going down this route of like cleaning this stuff up in terms of who needs to access what, is inside begin world change. What do we actually, what do we actually need the world mode for here, right? And the answer appears to be like nothing. If I just get rid of it, it's not necessary. It's funny how that happens, right? You end up seeing these things where you're like, gee, you know, like I was passing these things around because at one point I needed them, but as I start to like, you know, as this code starts to get bolted down a little bit more, it turns out there's stuff getting passed around that just doesn't need to get passed around anymore, right? Yeah, it's just simply not relevant. So now we can see that world mode isn't really even used in here because it's actually getting used for this sort of completely ancillary purpose of like camera management. So camera management kind of needs to be pulled out in a more coherent way there, so we can avoid having this sort of false dependence on world mode that we really didn't need, and it's just because it happened to be a convenient thing to do at the time. So let's take a look at what end world change needs here. And it looks like world mode, again, like you can kind of see what's going on here. It's really, there's a lot of camera management happening. Like all of the stuff for world mode here is camera management. Really, it's just the world structure that this thing needs. And the world mode is there really just for camera management, right? So that's, again, really big red flag here for us. Yeah, I think it's pretty clear that we kind of want to have a way of dealing with the camera that makes more sense than what we're doing now, because as you can see, the only reason we have to pass that whole world mode thing around is because we have on the entrance and the exit stuff that deals with the camera. That's not relevant for any other part of the world that we're updating. So the world in general, when it's updating, doesn't need to know this stuff. This is only specific to the a very, very singular case where we actually care about the camera being updated, and there's only one time that that actually happens. Right? All right. So let's go ahead and inside end world change here. I'm going to start passing world to it, just because that way we can sort of see that that's definitely happening. Go. Let's fix the other one here. There we go. And so really, I think what we need to do now is figure out how to make that camera handling be a little bit more reasonable, right? And then we're sort of down to the part where this is maybe starting to look like something that can be multi-threaded, right? That's not too much of a big deal to multi-thread. We're starting to get to a sane place for it, right? And really, at that point, the only thing I think we're going to have to worry about is when we take a look at the sim region stuff, we're probably going to have to do a little bit of locking around that world access, right? So, you know, begin sim and end sim, when we do the unpacking, the most sort of straightforward way to do that probably will be to, let's see, do we have that in here? Yeah. The most simple way to do it at first would be to just do it this way, where since we know that these are the two things that actually interact with the shared thing, we could just lock around the entire begin and end sim. That's a little more coarse-grained than we probably want to be in the end. So it's possible that we will want to lock the data more closely than that. And why do I say that? Well, if you take a look at what's actually happening inside Handmade World, you can see how things are set up in here. We've got a world struct, we've got a free list and a chunk hash, right? And if you take a look at how that works, we only really need to lock stuff when we are doing freeing onto the free list. We need to lock the free list. And for chunk hashes, we only need to lock the hash line itself. So if we wanted to, we could have a ticket per hash line even, and only lock that hash line when we're working on it. So, you know, this is definitely we could definitely do much more fine-grained locking and might want to, right? But at first, this is obviously a very simple way that we could make this piece of code work. And then what we would need to do is we would need to have a ticket that we could rely on that would allow us to lock and unlock this, right? So let's say that we had the world mode here, and we said, OK, you know, there's a simulation ticket or something like this. Well, actually, like I said, it's really, it's part of the world, so I think it should probably go on here, right? So if I want to change the world, lofty aspirations. If I want to change the world, then I need to be able to say, like, hey, take a lock on the world ticket and do what you're going to do, because only one person can edit that at a time. And hopefully that makes some sense, right? So yeah, I don't know how much time I've got left, probably not a whole heck of a lot, but the camera situation is definitely something we want to take a look at here. So here's the multi-threaded path, and like I said, it kind of runs into problems pretty quickly, and you can kind of see where those might be. Although, I'll be honest, I'm not really sure what that problem was right there. The world is null. The world is null. In begin world change. Why would the world be null? That seems odd, wouldn't you say? Do world sim. That was not really what I was expecting to see. So the world mode's world parameter got set to 0 somewhere down the line here, which is not what I would have expected. It looks like this is just getting overwritten prematurely, is what it would appear to be. Did I mess up the... Ah. Well, so one thing that is good to do when you actually say and then you call X is to actually call X. Unsurprisingly, since we did not actually wait for the work to be completed before moving on, it should not probably surprise anyone that we end up overwriting our own data. So yeah, Not great. I said we had to do that when I came through here, and I simply didn't type it in. Anyway, so yeah, in theory now, like I said, even though this is not really operating properly, so you have to take it with a grain of salt. We are now calling the world simulation code on multiple threads, at least in theory, and you can see it happening here, just so that we are aware of it. You can see that we've got 6 worker threads. It looks like 1, 2, 3, 4, 5, 6, all doing that work. And each of them is kind of calling. You can see if we pause, you can see that the worker threads are doing more than one in this case. And you can kind of see like there's begin world change, and right. It's kind of cool. I really love this little visualizer that we built. So you can see all of that work happening here. Meanwhile, up here you can kind of see that the game update code here is actually just kind of waiting. I guess what I would say is I'm a little surprised. I'm not sure why this thread is not actively doing any of that work. Oh, I see why. It's because it's inside game update and render. If I was to step in here, then I would see it do world sim. Yes. Okay, good. So anyway, we are now correctly multi-threading that update, at least to a certain degree. But one, of course, like I said, problem with this is that certain aspects are still not actually going to be locked properly. We did sort of the very coarse, crude locking version where we just prevent obvious errors from happening in the world read and write, but we still sort of have this weird thing with the camera and these other aspects of it that we're not really addressing properly, and that we want to be definitely more hardcore about. But hopefully you can kind of see the direction that that's going, and you can hopefully also appreciate sort of why I said, thinking about things in, it's not really functional programming, but it's the concept of, that's, I think very closely related, which is understanding specifically what a function does and does not need to access is pretty critical to moving towards multi-threaded code in any particular part of the project. Functional code is obviously the most multi-threadable because it literally doesn't do anything other than look at its parameters. But even things that are sort of beyond that, where they do edit things, do whatever, it's still the same general process. You're trying to like winnow away at the number of things that you have to access in order to sort of make it, something that can be easily run concurrently with other things that are that want to do like the same sort of operations. All right. So yeah. When looking at this as well, there's a couple things in here that probably, again, we can sort of take a look at more closely. But really, I think mostly what we want to do is figure out how to back away the back out that sort of camera stuff. So I'm going to say that tomorrow, probably what we want to do is take a look at that explicitly. So pull out the camera concept into something clear and optional. And then the other thing we want to do is where do things like typical for height live, etc. So we want to kind of like eliminate world mode from the sim step entirely. I think that's about it for today. So I'll go to the Q&A a little bit early, since technically I started 5 minutes early with the timer there. So if anyone has any questions about what we're doing here, please feel free to ask me. Please prefix them with Q:, so I can see them. Miblo is posting some questions sort of vicariously, or rather, Canuckles is asking the questions vicariously via Miblo, apparently. So what he says is 2 questions. Have you finished Sausage Roll? Steven Sausage Roll? No. Steven Sausage Roll is too hard of a game for me, I'm afraid. And 2, I have been shilling Shovel Knight for you, and you have to add Undertale to the list. That game is a gift from the gods on high. All right, so I haven't played Shovel Knight yet. I think I have it, but I don't think I've played much of it. I might have played it a little bit. And I tried playing Undertale a little bit, but I didn't see I didn't understand the attraction really. I could give it another go, but those are not really questions about the programming. So let's see. A pulsing mage isn't simulating the world in several threads. Can't that make the game non-deterministic? Isn't the point of the RNG having a starting kernel for deterministic play for competition and stuff? So I guess what I would say is that depends entirely on the game. For a game like Handmade Hero, we absolutely don't care about deterministic play. In fact, you might say that the point of Handmade Hero is specifically non-deterministic, right? Like, you want every time you play Handmade Hero for it to be completely different. It's very roguelike in that sense. So we don't care at all about being able to reproduce exact runs. And furthermore, we support variable frame rates on Handmade Hero as well, which also means that if we wanted to support fully deterministic play, we would have to do extra work to make sure that our simulation subdivided time properly and never took bigger or smaller time steps, even if the frame rate was bigger or smaller. So we definitely don't have any reason to want deterministic play on Handmade Hero, and so we're not concerned about that aspect at all. However, if you are trying to accomplish deterministic play, then yes, having multiple threads is a problem. You have to have ways of dealing with that fact and making sure that your threads don't add non-determinism if that's what you want. Most games don't try to be deterministic in the way that you're talking about, though, because remember, having a random number generator be deterministic from a kernel, usually we're going to care about that more during world generation, right? In other words, what we might care about is the ability for someone to say, here's a random seed, generate the world, and I want to make sure that on your machine and my machine, we generate the same world from that random seed. That is a valuable thing to use repeatability of the RNG. That's valuable for us, right? So we do care about it there. In here, we don't care about it at all, right? Because, again, there is no known reason that I can think of on Handmade Hero why we care about what the random numbers are that are generated on a run-through. I just don't know any reason why we would. If we did care about the RNG on the run-through, then we definitely have a problem. And here's the reason that we have a problem. I guess to sort of sketch out the answer to the thing, which I mean, I think you kind of already know this answer because your question kind of begs the answer to begin with, right? But let's say that we take a look at the typical use of some of the entropy that's coming in through the game. So, I've got, my hero here, and he's going to like punch at somebody, right? And maybe, there's the monster here, right? The spider monster with the big fangs or whatever, or something like this. So I'm going to punch at this monster, and I hit the monster, and so then we do some kind of a roll for damage or something, right? I don't know what, this is awful. What is with the penmanship today? Roll for damage. So, maybe I'm going to do something where okay, I have a certain percentage chance of getting a critical hit, right? Well, there's an RNG roll, and that, there's an RNG roll that needs to happen there that's going to determine whether or not I get that critical hit. That's a source of entropy that I would argue you almost never care about whether it's deterministic, right? Because two players playing the same seed aren't even going to be punching at the same spider at the same time, so their RNGs are always going to be in different states anyway, right? They haven't even rolled the same number of rolls at this point. So that source, I would say, is not particularly relevant in terms of caring about divergence of the RNG because of multi-threading. However, if there's a chest in the game and it's like, what's in the chest, right? And the random roll for what's in the chest is dependent, let's say, on something that can happen in the game, like whether you've got a lucky charm bracelet on or something like this, there you might care more, right? You might care if the RNG for chests is consistent across playthroughs or something in this way. So I could see an argument for isolating the RNG here. And if you wanted to do that, you could, because all you need to do for that is have a locked RNG you use for special rolls you want to make consistent, right? But I would say in general, trying to ensure consistency of the RNG in this way may be a little bit of a fool's errand. Because again, two players' paths diverge almost immediately out of the starting gate. So the question is, what are you really ensuring when you ensure that the RNG is consistent? Really, all you're ensuring is that for the exact same set of inputs, you'll produce the same run. How much do you care about that, right? That's not really the same as saying that it's fair for both players or something like that, right? So yeah. So the thing that I care way more about, I think most of the time, is RNG for the world gen. And that's much easier because we don't have to multi-thread that if we don't want to, or if we do, we can take steps to make sure that it doesn't diverge. So I think that's the place where we're going to care a lot more about that. The geek part, when do you go back and complete to-do tasks you've given yourself in the code? Is each one going to be completed before you're done, or are they simply wish lists? Basically, they're just notes to myself for when I go to ship. So when I'm very, very close to being done, I'll often grep for all my to-dos, and then I'll go through them all and decide which ones of them are still relevant and need to get done and which ones aren't. So the answer is that some of them will turn out to be wish list things that just get ignored. Some of them will turn out to be priority items that have to get fixed. And really, it's towards the end of the project that that's relevant. Is it important for a game programmer to have a portfolio in the same way artists do? And if so, what would be important to include? I would say maybe wait for Handmade Con for that question. I don't do a lot of hiring anymore. I'm not involved in hiring programmers. And so I am kind of out of touch with what people screen for your first sort of, when you're trying to get into the game industry. It's been too long since I've had any contact with that process. That is a question I ask every year at Handmade Con. This year will be the same as last year. I'll be asking. In fact, the person who I'll be asking that question of very specifically is the tech director at Blizzard on World of Warcraft. They do a ton of hiring. It's the kind of job you might hope to get when you're starting out in the game industry, doing some fairly basic task on World of Warcraft or something would be a good entry-level position, for example, because they're a good company, there's a lot of people to learn from, it's a famous game. And so I'll definitely be asking those kinds of questions. And so this, next week is Handmade Con. I'll be asking those questions, and we'll have some, again, a different set of answers. If you can't wait till then, go watch Mike Acton's segment from Handmade Con 2015, last year's con. He was the tech director that I invited last year, and he answered that question as well. Gary Johansson, in a tight inner loop, do you think these memory copies for the temporary scratch memory could become an overhead concern if I understand the stream correctly, that is? I'm not sure what you mean. Certainly temporary memory copies are always a concern. So the chances are the answer to the question is yes, but I'm not sure I know which temporary scratch memory copies you're talking about. So if you could be a little more specific on that, I could answer the question directly. Long Boolean, currently what is the behavior when walking several rooms over into another chunk? Well, right now the simulation stuff is just kind of running randomly out in the world. So you would never, you can't get to a chunk that's being simulated because they're offset from the place where you currently are, if that makes sense. Save. William Bundy just said save scumming. I don't know what save scumming is. Jim Zero, will there be streams for the job fair people? No. The job fair stuff is not recorded and really can't be. There's so many teams participating in the job fair now. There's like, I don't know how many there are, but it's like way more than anyone could possibly film. What's the relation between IQ and success at programming? I have no idea. I literally have no idea. I know a lot of great programmers. I don't know what their IQs are. So I don't know. While I can point to great programmers and say these people are really good at what they do, I can't then tell you their IQ is this. Ginger Bill has a question. Off-topic question which can be answered later if necessary. I've been developing a new programming language to replace my needs for C, C++, and pretty much every other language. The main areas of research for me at the moment are metaprogramming, SSA optimizations, concurrency. You being a metaprogramming expert, other than compile time execution, that is John's language, what other forms of metaprogramming would you like? Yeah, that's kind of a bigger question. I probably can't answer that at the moment. William Bundy, sorry, it was in context. If I open a chest and don't get what I want, reloading a save game and playing slightly differently might get me a different RNG for the chest. Yes, exactly. And that's why I say if you want to be specifically concerned about specific elements RNG-wise, you can take extra steps there. However, I would point out kind of the obvious thing, which is that I don't know that save scumming is really something to be that concerned about, because at the end of the day, if someone just wants a different thing in the chest and they're going to be going the like mess with save game routes to do it, they could easily just figure out where the RNG number is stored in the save game and edit it, right? So I'm not sure that that's really all that much different. You know, if people are trying to cheat, they can. And you're really just talking about how much of a barrier you're trying to erect for them. My tact is usually, I don't really think it's that productive to erect barriers to single player cheating, because if someone wants to cheat in single player, just let them. It's their game, they bought it. I don't care how you want to play it. If it's fun for you to play the game that way and you would prefer to do it, then that's okay with me. I probably would recommend some level of barrier. Like, I wouldn't just have it so you press X to win the game. And the reason for that is I want to help people who don't want to cheat. I want enough of a barrier there so that those people don't feel constantly tempted to do it. I want to help them have some step there. But as long as there's some significant step you have to take in order to cheat, that's enough so that regular people who want to play the game and don't want to cheat aren't constantly tempted to do so, then I don't think the programmer really should go any further out of their way. If someone wants to sit down and start cheating at a game, and it's a single player game, so you're not affecting anyone else, then I don't see the crime in that, right? It's like, it's their game, they bought it. You put up enough of a barrier to make it so that it wasn't trivial to cheat, so it doesn't become this problem temptation-wise for players who don't really want to cheat, then I think you've done your job and you're pretty much done. Will the game have different levels like The Binding of Isaac, or will the entire game be a single level? I don't know that we'd have any levels in the sense that there would be like breaks in between them. No. So everything's continuous. You can just go to anywhere in the game when you're walking. You wouldn't have a loading screen, certainly. All right, are we basically done then? Maybe? I think we should probably be about done, because I probably should go get some lunch or something. Let's go ahead and wind it down. Okay, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with a source code. I keep it up to date every night so you can experiment with what we're doing on your own and learn from it. We also have a forum site you can go to if you want to ask questions, a Patreon page you can go to if you want to support the video series, and a schedule bot that you can look for or subscribe to if you want to know when the series is going to be live. I will probably be updating the schedule bot soon so that it is going to do the weekend streams properly now that we do the 2 back-to-back, which previously we hadn't quite ever had support for that because we never did it before. We also have an episode guide if you want to catch up with old episodes, which is pretty awesome. All right, thanks everyone for joining me. I will see you back here tomorrow for another 2-episode block. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.